this video, I'm going to be looking at how we can calculate the gradient of a straight line. Now, gradient is a fancy maths word, but all it means is the slope of the line, how much we are going up by with our line. So you can see here that this line is not flat, it's not horizontal, it's not vertical, it's going up, it's increasing. So this line is going to have some form of gradient that we need to measure, because it'd be useful to know, is this going up quickly, is it going up slowly? And the only way to do that is to attach some kind of number to it. The number we're going to be using is the gradient. So from a more measurable standpoint, the gradient is going to be based on what happens when we move along one square. So you can see here I've marked off one square in the x direction. So we've gone along one square. And the question is, when I go along one, how many do I go up? Well, in this example, I go up one. So for every one square I go along, I'm going up one square. And that's one way to arguably describe the gradient, is how many squares up are you going for every one along. And you'll notice that that is exactly the same no matter where on the graph I am. So even right at the bottom here, we're going one along and then one up. These little triangles are the same all the way along. And that's important to know, that the gradient of a straight line is the same all the way along the line. That isn't true for other types of line, but if it's a straight line like this one, the gradient doesn't change. So the gradient is exactly the same all the way along. And we've got another definition for gradient. We've already said it's the slope, but more technically, the gradient of a straight line is the amount y increases by when x increases by 1. So the gradient of this first picture is 1. Here we've got two more graphs, so I'll start with the one on the left. When we go 1 along on the x-axis, we go 2 along in the y-axis. So the gradient of this line is 2. Looking at the next graph, when I go 1 along in the x-axis, I'm going half up in the y-axis. So the gradient of this line is a half. Again, starting with the one on the left, when I go 1 along in the x-axis, I go 3 up in the y-axis. So the gradient of this line is 3. For the one on the right, when I go 1 along in the x-axis, well, our problem here is I'm now going to go down. I'm going to go down 3. But if you're comfortable with negative numbers, you will hopefully see that going down by 3 is essentially the same as going up by negative 3. So the gradient of that first one was 3, and the gradient of the second one is negative 3. So we can have negative gradients. Okay, now here we have another picture, but this one we come to a bit of a problem. So if I look at what happens when I go 1 along, I can see I'm going 1 and a bit up. Now my problem is, at the minute, I can't quite tell what that bit is. It looks like it's about 0.4. So my gradient would be about 1.4. But that's not very accurate, that's not very exact. I'd rather know exactly what my gradient is, exactly what I'm going up by. So this idea of gradient is not going to help me anymore with pictures like this. The idea of how much do I go up when I go 1 along is useful in simple diagrams, but it's not particularly helpful here. I would like a different way to look at the gradient. Now what I can see very easily, I can't see what y goes up when I go 1 along, but I can see really easily that when I go 3 along, I go 4 up. I can see that because both of those exact coordinates are on the line. So when I go 3 along, I end up going 4 up. Now that is a useful observation, because by going 3 along, what we've essentially done is we've gone 1 along 3 times. So you can see that that 4 there, that 4 up that we've just described, is actually just 3 lots of this 1 and a bit that we've already described. It's 3 lots of that 1 and a bit going up. So because I know that all 3 of these added together make 4, and they're all exactly the same, I know that this is not just 1 and a bit. This is 1 and a third. This is 4/3. 4 divided by 3, it's 4/3. So the gradient of this line must be 4/3. That way of thinking actually gives us an even easier way to work out the gradient. A simple formula that, if you remember, will always help you find the gradient of a straight line. That formula is m is equal to the difference in y divided by the difference in x. Now this m here is just the standard letter we use for gradient. Do not ask me why it's m, it's just we tend to use the letter m when we're talking about gradients. So the gradient is the difference in y over the difference in x. Now this is quite a lot to write out, so we do have a bit of shorthand for this. We sometimes write this delta to mean difference in. So by delta y, I mean difference in y. By delta x, I mean difference in x. So this notation isn't necessary, you don't have to know it, but it is quicker to write than difference in. So we now have a formula. So in a minute, we're going to use this formula, find the gradient of some lines. But before I get onto that, there is a little note that we need to be aware of, just to make sure that we're not making silly mistakes. Because we noticed already that we can have positive and negative gradients. We can have 3 or -3 as our gradient. So what does this actually mean? These numbers, what does that actually mean? Well, m is going to be positive if I've got an uphill line. So most of the pictures you just saw were going from the bottom corner to the top corner like that. That's an uphill line. M is going to be negative if we're going downhill. So that is something else that you need to remember, you need to know. It's going to be positive if we're going uphill, it's going to be negative if we're going downhill. So I recommend you use the following process when you are trying to find the gradient. Firstly, I recommend that you check whether it's going to be a positive or negative gradient. And you can do that by seeing if the line is going uphill or downhill. Secondly, you need to find any 2 coordinates on the line. It can be any 2 coordinates at all. As long as they are on the line and you know what they are, that's fine. You are then going to find the difference in y between those 2 coordinates. So we're going to look at the y ordinate of both coordinates and we are going to see what the difference is. You then need to find the difference in x. So in the exact same way, you're going to find the difference between the 2 x ordinates. And then finally, you can use the formula to find m. So you can use the fact that m is delta y over delta x. It is the difference in y divided by the difference in x. So this is the process I'm going to be following in my examples. So let's start with this graph here. Is this a positive or a negative graph? Well, clearly we're going uphill. If you imagine you were driving from the bottom corner up here, you'd be going uphill. So this is a positive graph. I then need to find any 2 coordinates, and I've got lots of options, but I'm just going to pick these 2. It's normally a really good idea to pick the integers if you can. So the reason I chose these 2 coordinates is because I know that they are both integer values. So these are the coordinates 0, 0 and 1, 5. I then need to find the difference in y. So I can do this by looking at the numbers, or I can do this by looking at the picture. So in the picture, I can see I've gone up 1, 2, 3, 4, 5 squares. So that'd be 5. If I just looked at the numbers, I can instead do 5 take away 0, because it's the difference between these two y ordinates. It's the difference between 5 and 0. So either way, I get 5. To find delta x, again, I can see that the difference between these two coordinates is just this 1 square, so that's 1. Or I can look at the numbers and I can go 1 take away 0 is 1. So that means that the gradient of the line is 5 delta y, which is 5, divided by 1 delta x. So the gradient is 5. And in fact, using our last method, we'd have got the same thing. We can see that for every 1 along we go, we get 5 up, because this method is equivalent to that other method. Right, let's have a look at another example. So this graph is going downhill now. If you imagine we were in a car driving along the x-axis, we would now see that we are going downhill. So this is going to be a negative gradient, which means I'm going to need to get a negative number at the end. Sometimes that will happen anyway, and the numbers will work out, but if it doesn't end up that way, you need to make sure that you know your answer is negative. I then need to find any two coordinates. So I pick these two. I picked -1, 3 and 0, 0 as my two coordinates. I then need to find delta y, so the difference in y. And again, I can do that with a picture. According to the picture, I've gone up 3 squares. So that would mean my answer has to be 3. If I look at the coordinates, then it's 3 minus 0, which is 3. To find delta x, again, on my picture, that's clearly 1 square. Or I can use the coordinates and see that it's -1 take away 0, which is -1. Also, you'll notice that when I looked at my picture, I decided the answer was 1, but when I got the numbers, my answer was -1. Now, of course, that's because the numbers are taking account of the fact that we have a negative gradient. We don't always notice that when we're just looking at counting the differences here and counting the squares between them. We don't always notice that it's negative, which is why this first step is really vitally important. But either way, we are going to agree that it is -3/1, because it has to be negative and it has to be 3 divided by 1. So the answer is -3/1, which is just -3. Okay, so what's the gradient of this line? Firstly, I can see that we're going downhill again, so this is going to have to be a negative gradient. I then need to pick any two coordinates. I'm going to choose these two, which are the coordinates -3, 3 and -2, 1. I'm going to find the difference in y. If I look at the picture, it would appear to be 2. If I run the numbers, 3 take away 1 is 2. Delta x, again, I can see the difference here is 1. If I run the numbers, I get -3 take away -2, which is -1. Fine, because I know my answer is going to be negative anyway. So it almost doesn't matter what the sign is here, because I know my answer is going to be negative, so I can just make sure that it is negative. So m is going to be -2/1, which is -2. Okay, what's the gradient of this line? Well, firstly, it has to be positive because it's clearly going uphill. So this is going to be a positive answer. I can then choose any two coordinates I like. I'm going to choose these two. So that is -6, 0 and 3, 3 are the two coordinates I picked. I then need to find delta y, so it's the difference in y. If I look at my picture, I can see that it's 3. If I look at the coordinates, the difference between 0 and 3 is again 3. So in fact, I've done 0 take away 3, which gives me -3, but again, we don't really worry about the signs. That's not what's concerning me. What I'm worrying about is making sure I've got the numbers. And the difference in x, so we're going from -6 up to 3. So this is a 9 square gap. And if I do -6 take away 3, I get -9. So again, not worrying about the sign. The fact is that I did get 9, which is what I wanted. Then the gradient is the difference in y divided by the difference in x, which is 3 over 9, or to simplify it, 1 over 3. So here we've got a fractional gradient. That's possible as well. You can have positive or negative gradients. You can also have fraction gradients. Here we've got another line. Now looking at this, we're going downhill again, which means this has to be a negative gradient. I need to choose any 2 points on this graph. So I'm going to choose these two, which are the points 0, 0 and 2, -3. I then need to find the difference in y. So looking at my picture, I can see that I've gone down 3. Or if I run the numbers, I can do 0, or sorry, -3 take away 0 is what I've actually done, but 0 take away -3 would have worked as well. So we get 3, it's the important part. And the difference in x, we can see on the picture that it's 2. And if I do 2 take away 0, I do indeed get 2. Which means my gradient has to be -3 divided by 2. I could change that to 1.5 if I wanted to, but I'm going to leave it as a fraction because there's nothing wrong with fractions. I quite like fractions. Okay, the key points from this video. The gradient of a line is the amount it goes up by, or the slope. So this is just a fancy new word for a fairly simple concept. Another way to put this is that it is how much y increases by when x increases by 1. So that's just another way to word the definition of a gradient. A positive gradient is one that goes uphill, and a negative gradient is one that goes downhill. Now this is the biggest mistake that people make in these questions, is they don't notice whether it's supposed to be positive or negative. Make sure you always know if you're going uphill, you need to get a positive answer. If you're going downhill, you need to get a negative answer. We only need 2 coordinates on the line to find the gradient. And once we have chosen those 2 coordinates, we can use the formula m equals delta y over delta x to find the gradient.